Good afternoon, everyone. Thank you for joining the webinar this afternoon. So I sit within the Bytes Vendor Solutions team, and we have put together this presentation as a joint offer from Cintra. Bytes have partnered with Cintra for the last 18 months to 2 years, and Cintra are one of the top 5 platinum partners in the UK, and have over the years won numerous awards in the States and the UK. So just really want to kind of go through, there's quite a few areas that we would like to go through today in terms of database consolidation, depending on which version you sit on at the moment, and then helping you understand how Bytes Cintra can help you on those particular projects, whether it be moving to, kind of a version 11G, or if you are looking at some of the new options that are available in 12C, then that's something we will cover, or if it's just looking at re-architecturing your estate. But the idea of us having a joint partnership is so then we can offer our customers an end-to-end solution when it comes to Oracle. So having the licensing approach and helping you understand your licensing estate, as well as helping you with projects where we can do the deployment and consultancy. Cintra have a global presence, and they are a full-on Oracle partner, so that's their speciality. The guys that have put together the company, they are all ex Oracle guys as well, so very familiar with the channel and Oracle, kind of breathe Oracle day in, day out. So I'll now let Simon jump on and cover the 12C messaging.
Great, thank you, Sonal. Okay, good afternoon, everyone. Thanks for joining. So yeah, my name's Simon Rice from Cintra. I'm a database solutions architect. My background's actually around 20 years as an Oracle DBA, which is I don't know. You probably get less than that for murder. So, possibly a sad thing, but that's where I'm coming from, and I think that's kind of relevant in terms of this presentation, as my job has traditionally been to keep the lights on in Oracle environments. So Sonal's already given a good background on Cintra. I think the one thing I would add is that one thing that's really part of our DNA at Cintra is reducing risk and making things guaranteed and predictable. We do that through everything really, from whether it's a database upgrade, using Golden Gate to make it faster, or real application testing to make it more predictable on the performance, whether it's deployments where we have very blueprinted and rigorous processes around hardware and software compliance and so on, or whether it's proactive support at the end of the day. The reason I mentioned that is that we're probably one of the last people to jump on the bandwagon or drink the Kool-Aid, depending on which metaphor you prefer, when it comes to brand new releases of anything, whether it's Oracle or iPhones. There's typically a reason why they call it the bleeding edge. So really, I think our presentation today is to talk around what problem are we trying to solve with Oracle Database 12c. What features do we see that can solve that problem, and really what reasons are there to jump on board with that right now, or should we be looking to wait a while for that to mature? So and I think our specialization here at Cintra really just speaks to the fact that we grew up as a database consultancy, and have more recently grown into an engineered systems world as well, as many DBAs are having to. I think when you start to approach platforms like Exadata and Supercluster, you're no longer just a DBA. You become more of a machine administrator, and your horizons need to expand somewhat. And Cintra's growth over the years speaks to that kind of journey as well. So yeah, in terms of the problem we're trying to solve in IT and in general in any capacity, I think this diagram says it all nicely. And certainly when we look back, not just over the last 4 years, but perhaps even over the last 20 years, the amount of data we store is significantly more and it's growing exponentially. And you know, when we start to look at the amount of data we store on mobile phones, on personal computers, and so on, it's ridiculous compared to what it was a few years back. Conversely, and this diagram shows IT budgets increasing marginally. You know, my experience has been that perhaps even that's not the case, that we may even see IT budgets decreasing. And the message that we're given in terms of providing an IT service is how do we do less? How do we do more with less? You know, how do we reduce our data center footprints and costs? How do we improve our operating efficiency without the need for a huge hike in our IT budget? So really our presentation today is talking around how Oracle Database 12c, what features are within 12c which can influence that kind of issue. There are 500 new features, as they say, in Oracle Database 12. So there's a lot that we're not going to cover here, but I think we're going to cover a lot of the key points that you'll find of interest. So when we look at database architectures, we have various metrics that we look at. And we see we have a number of clients out there in the marketplace running legacy, big iron platforms still. We see many people running silos of architectures where a specific application has a specific set of app servers, a specific set of database servers, its own dedicated storage, and you end up with these silos of database and application technology per service. There are also issues around whether we scale vertically with larger servers, with just spreading out the tree, or whether we go horizontally scaling via adding cluster nodes, and how we consolidate onto those clusters as well. There's a lot of work we do around how we manage the life cycle of our data, which we'll talk around here, and how compression feeds into that, and leveraging different tiers of storage. So jumping in, here's an example of a very siloed architecture, and this is something extremely typical across organizations. Here, as you can see, there are lots of different applications. These are actually spread across numerous data centers. We have everything here from Windows, Alpha servers, Linux servers. On the middle tier, we have lots of different products, lots of different versions of WebLogic. What this equates to is an extremely high cost in terms of data center management, but also an extremely high cost in terms of Oracle license footprint. 54 processes of Oracle Enterprise Edition. We're looking at even more than that in terms of WebLogic Enterprise Edition licensing. So as Sonal mentioned, one of our goals here is really to make the most out of our software license investment. So what do we look at when we look at an architecture to see whether it's ready for this kind of data growth? Really what we tend to do is look from the bottom up and look from our storage first of all, and in terms of what kind of response times are we getting from our storage, as well as things like our backup and restore times, our business service levels around backup and restores. Also our requirements around how we do our backups and the capacity that we have available. We also look at things like how much data we're using in terms of gigabytes, and whether we have any compression there, and the gateway that we use to get to that data, whether we're using fiber channel, FCO, NFS mounting, and what protocols as well as what bandwidth we have to that data. On the network, we're very interested in the round-trip response times as Oracle sees it. It's very easy to get into a battle where your SAN administrator is saying, hey, I'm seeing 5 millisecond response times, but as a DBA, your AWR reports are showing that you're seeing 25 millisecond response times. And where does that latency come in? Is it file system caches? Is it network bandwidth limitations? So that's another thing we look at. And then really that all builds into our expectations of user experience on the front end, how that translates into real-time transactions and business reporting and batch processing, depending on the application. So what we try to do in terms of a smarter approach here is, particularly on the storage side, lifecycle management of data is absolutely key here. And we'll talk in a minute around how 12c influences this picture. But even with 10G or 11G, we have the option of partitioning level of compression. And we have a lot of options for compression. We have advanced compression basic compression as it existed in 10G, where we can do a direct path compression of direct path loads. We have advanced compression, which opens a lot of doors in terms of compressing lobs, in terms of compressing data via regular DML. And then also in 11G, we have the option of leveraging hybrid columnar compression, either if we're on an Exadata platform or if we're using ZFS storage appliances from Oracle. So we have lots of different options of compression, and those options each come with their own overheads, be it CPU, normally on the database servers. So what we really want to do is have a process where our most active data is uncompressed and is on our top-tier storage, so that we get that fastest and it's accessed and updated fastest. Our less active data can go on a second tier of normally lower spec storage. Could be RAID 5, could be SATA drives instead of SAS drives, for example, and it could be compressed using advanced compression or HCC. And then our very inactive archive data typically goes on our lowest tier storage and has the highest degree of compression available to us. The other thing to mention here is that we're seeing storage platforms evolve significantly, and we now have products on the market like the ZFS storage appliance, which produces a hybrid storage pool that uses not only the the RAM in the controller cache as an I/O cache for reads and writes, but it also has read SSDs, write SSDs as well, and obviously the back-end drives behind that. So even on the SAN and the NAS space, we're seeing storage providers move much more into, I guess, the same kind of mindset as Exadata, where we really want to minimize the number of times we hit spinning drives and maximize the number of times we're hitting memory or flash or SSD for that improvement in performance. On the network side, I guess we've seen some advances. Typically we see people who are running fiber backends move from 4 gig to 8 gig fiber. We see a number of people running over 10 gig Ethernet using NAS as their protocol there, using NFS over 10 gig. And we can active bond that on the network card, so we can effectively double the throughput up to 20 gig. InfiniBand, as I'm sure you know, gives you even more extreme throughput than that. In the newest Exadata release, there's going to be a new patch called Direct-to-Wire, which is, in fact, even going to double the throughput that we get on InfiniBand by reducing some of the latency in actually making the InfiniBand calls. So we're seeing some significant advances there in terms of how the network's used between the database servers and the storage. I think the other thing which is critical here is a high-speed cluster interconnect if you're running rack. And we've seen a number of clients get into a bad place with either trying to do stretched rack or trying to use things like shared VLANs for cluster interconnects over 1 gig in Ethernet, for example. In terms of memory, I think the key thing here is that memory is relatively cheap and relatively large these days, even considering some of the large volumes of data. Both on the storage side that I mentioned, the ZFS storage appliances, the larger of the two now comes with 2 terabytes of RAM in each controller head. So effectively, you can cache 4 terabytes of data in the controller itself without even reading from disk. On the database servers as well, for example, the Oracle Database Appliance or the Sun Intel servers have much larger caches now. So I think really the message there is that it opens the gate for consolidation a lot more than we previously had. The idea of only being able to fit a couple of databases on a database server, I think those days are behind us. I guess the other point lastly here, which is mentioned on the slide, is database in-memory caching with Exadata. Not only do we have huge amounts of cache, 22 terabytes of cache in Exadata X3 now, but we also have the ability to compress data in those caches as well. So the benefits of compression not only cascade on the storage layer and reduce the amount of data that's read and written on the storage layer, but they also improve the efficiency of our memory caches as well there. In terms of CPU, this is kind of a double-edged sword, but CPU compute power has improved a lot. Even just looking back on Intel processors over the last few generations, the Sandy Bridge processors were around a 40% improvement in terms of CPU processing power over the previous generation. The new X4 models of Exadata and the Oracle Database Appliance are on the way. They'll be coming with the new Ivy Bridge processors, which are 12-core CPUs. Now, obviously the double-edged sword aspect of that is, okay, great, we have 12 cores per CPU. However, we need to license those cores as well, especially if we're running Oracle Enterprise Edition. So, not only, I guess we either need a smarter way of managing those CPU cores and the licenses that are tied to them, or we need to more effectively consolidate onto those to make better use of them. So, just in terms of the upshot of that, and these are some stats from online businesses. eBay, as you would expect, has a huge number of hits per day. Facebook as well has a huge number of unique visitors per month. The average UK online retailer is a fairly medium-sized UK business, which we're seeing around 10 million hits a month. But I think the message here is not only for online retail that if you snooze, you lose, and potential customers get bored and move on, but also in any business, whether it's a departmental system where an administrator's wasting time in their day because the system's slow, for example, or it's not going to scale to allow your business to grow. I think any business has aspirations to grow, and any online business wants to be eBay or Facebook, if they're honest, I think. So I think what we need to do is not limit ourselves by the IT infrastructure at the back end. Our message here is we really need a quantum leap in our IT infrastructure. We don't just need incremental updates because we've added some more memory DIMMs or we've added a slightly faster CPU. What we really need is a platform and a software platform as well as an infrastructure platform that enables us to make this kind of quantum leap in our business capabilities and our end user experience. The way we go about doing this is we really need to integrate some of the teams which traditionally have barriers between them, and particularly we're looking at teams like the systems teams and the DBA teams and the application teams. We really need architects to span those bridges and have an oversight of the entire platform. I think the days of being able to work in a silo and say, hey, I'm just a storage guy, those days are really coming to an end if we want to achieve these kind of goals. Removing complexity is key in simplifying it as well. Again, I think the days of being able to say, hey, we've got a bunch of Windows systems, we've also got some Linux systems and Solaris systems. Just the overhead in terms of keeping people trained up in Red Hat 6 and Solaris 11 and Windows, whatever. It's I think the overheads there are very very key, and not only, and it becomes exponentially worse when you start introducing SQL Server and MySQL and other database platforms into the mix. The more we can simplify things, the more we can consolidate, the easier we can manage the environment and maintain it, and the more agility we have there in terms of deployments and provisioning. So really this comes down to the message of database as a service becoming a key technology out there. And we've seen it called a number of things over the years, and it's really nothing new. I think it's just that we're seeing more of a driver towards it these days. And as this survey back a few years ago says, the key goals are around consolidation and saving costs through operational efficiency via that consolidation. I think some of the nice features around showback and chargeback are great, but they're not typically the reasons why people go for database as a service. And just to kind of give you, I guess, an overview, database as a service is effectively building your own cloud infrastructure internally within your company. So really it's the same data center you've always run. It could be the same type of database servers and storage that you've always run. What database as a service is giving you the ability to provide users an environment in which they can consolidate and in which they can automatically provision things, and in which they can effectively you can charge them for that service. So moving on to Oracle Database 12c and how that allows us to do this, and really how it compares with 11g. In 11g, we've seen, and previous versions of Oracle as well, we've seen lots of people make use of virtualization technology. Sometimes that's logical virtualization, sometimes that's physical virtualization through things like LDOMs and LPARs and Solaris zones. Logical virtualization through things like VMware has been successful in terms of deployments, but not so successful in terms of reducing license footprints. Oracle still licenses you for the physical host that you're running on, which is a consideration there. Even if you're running, for example, Solaris zones that are physically virtualized, the cost you pay there is that you're still running multiple versions of the operating system, multiple versions of your memory caches, and all of those things require server resources. And to increase the consolidation, we can obviously put multiple databases on the same server and the same operating system, which gets away from that, but you're still running multiple versions of your Oracle background processes and multiple SGAs and PGAs for each of those Oracle instances. We can also consolidate schemas onto databases, which is a good model if we're able to do that, but is typically prohibited by the fact that different applications have different security environments, the security requirements, and in most cases, application owners don't want their data to cohabit with other applications. It's typically seen as too much of a business risk. The way 12c changes that is the ability to have pluggable databases where we have a single container database and multiple databases that plug in within there. So I'm going to drill down a lot more now into what the pluggable database gives us and how it's managed. So in a traditional architecture, as I mentioned, if we have three instances here, we have our ERP, our CRM, and our data warehouse instances. Each one of those requires memory, it requires background processes, and it has its own specific set of database files with its own specific undo table space, temp table space, and redo logs, all of those structures. As you can see here, if you put three of those on a server, in theory we may max out that server. The idea is with pluggable databases here that we can literally upgrade those databases to 12c, plug them into a single container database, and then we only have one set of SGA and PGA, only one set of background processes, and so on. So we have a number of ways we can upgrade and convert databases from standalone 10.2, 11.1, 11.2 examples here, databases into a 12c container. And really, the most simple of those is just to do an in-place upgrade from 10G, for example, to 12C. And literally, those databases can then just be straight plugged into our container database. And it's a very, very rapid process, probably not as magical as PowerPoint shows it to be, but it's still a very rapid process to plug into our container there. The efficiencies we see here are huge, and I have to say I was a skeptic at Open World when they announced this as to what the real benefits would be, just sharing an SGA and a PGA and some background processes. But really these figures speak for themselves. We've proven that you're able to fit 5 times more databases on a server if you're using 12c with pluggable databases and multi-tenancy than if you're using standalone databases. The resource usage on the hardware side, particularly in terms of memory, is even more substantial. We're using 6 times less resources, but can fit 5 times more databases on there. So, I think the case for multi-tenancy and pluggable databases speaks for itself there. In terms of how we manage the resources there, we have complete transparency around the resources for each individual pluggable database. There's no limitation that we're running a container database, so we can only see the resource usage for the container. We can see the resource usage for the actual pluggable databases itself. And we can adjust those and give them different priorities using the database resource manager toolset for each database. So in this example here, we can give our ERP database the highest priority, our CRM medium priority, and our data warehouse a lower priority. And we can also adjust those priorities throughout different windows and control that using the maintenance window features there. So as I mentioned, we have different patching and upgrade options here. We can apply patches in one hit, which is typically a desirable thing, that we can have a window to do that. and that's available. You can actually upgrade and patch all pluggable databases within a container for both smaller patches like our PSUs and SPUs, or we can apply a patch set, so upgrade from 12.1 to 12.2, for example, for every pluggable database within a container. The other option we have available to us is we can actually have an upgraded container database running alongside our original container database, and actually just take databases one after the other, plug them into our upgraded container database, run a fast script on those to upgrade the data dictionaries with the new objects of the new version, and take those piecemeal as well. So if we're in an environment where we need to spread that downtime a bit more evenly, we can do that. The other nice feature here is backups. We can back up an entire container database, using a single backup, and we can do point-in-time recovery of pluggable databases at their individual levels. So, you know, the backups benefit from backing up everything at once, whereas a point-in-time recovery can be performed at the local pluggable database level. In terms of how that converts into a data guard environment, we have the really nice feature of just creating a physical standby database for our container database, and then that then carries across all of the pluggable databases within it. So if we add here a new database into our primary database in our primary data center, that is automatically created as a physical standby copy on the standby site. And again, it should be noted on the data guard side, we have the flexibility that our physical standby is a single copy of our container database, but we can actually switch over and fail over individual pluggable databases within there. So again, we have the multiple levels of granularity there. The cloning into development and test environments is very cool. We have a number of options which I'll talk about in a minute as to how we do that. One great feature is we can take a copy of our ERP database here, for example, over to our development container database, and within that container database create a number of clones. As I say, I'll drill down into how we can create those using RMAN or cloning technologies. So what this really gives us in terms of an environment is a container database, many pluggable databases, and each of those pluggable databases is 100% private and 100% secure, and we can have different security requirements for those, whether they fall under, for example, PCI or Sarbanes-Oxley, as opposed to, you know, less secure environments, all within the same container database and sharing the same operating system resources. So I think the key takeaways from this is that the multi-tenant architecture gives us a huge improvement in terms of resource utilization and the ability to manage many databases as if they were a single database. Makes it much more performant and scalable, but it's also transparent to the application. There's nothing you need to do on the middle tier to redirect applications from a single instance database into a pluggable database. All of that's 100% transparent there. So the other couple of features I wanted to talk around here, the first one is around automatic data optimization. Now, as I mentioned, we've had policies for a number of years now around lifecycle management of data, and it's been a very effective way of maximizing our storage usage. What 12c allows us to do is create policies for automatic tiering of data, depending on what Oracle calls a heat map of that data, where hotter data is more heavily accessed and heavily used data, whereas colder data is less accessed archive data traditionally. So what we can do here, and this is a typical scenario that we recommend, is have basic compression on data where it hasn't been modified for 30 days. So as I mentioned, our current month we would typically have uncompressed and have that for best performance. Anything older than a month, between 1 month and 6 months, we would use basic compression or advanced compression there. And if it's older than 6 months, then we could use hybrid columnar compression if we're using ZFS or Exadata. The way 12c feeds into that is it builds up a heat map. So here it's obviously showing us that our most accessed data is being updated heavily. So it's shown red here, but is in terms of Oracle the hottest level. Our less updated data is still selected from. It's given a slightly different heat map. And what we end up building up over time is our most accessed data is showing as red here. Our less accessed data is less updated or is only selected from, so is more of a medium heat map. And then our colder data, shown in blue at the end here, is still selected from but less frequently. And what we can do here is we would typically use hybrid columnar compression on these blue objects, which are selected from infrequently, use advanced compression or basic compression on our medium heat map records here, and use no compression at all on our heavily updated hot records, the very most recent data. It is worth mentioning, though, that this relies heavily on partitioning technology. It's very, very difficult to do this sort of thing without partitioning. So that's when our data sets start to grow and things like enterprise editions start to be a must for the size of the databases that we're looking at, particularly when we're getting probably over 700 or 800 gigabytes up to a terabyte. Partitioning is really the way to go there to manage that. The other extremely cool feature in 12c, 11g gave us the ability to scramble data effectively, to scramble our data sets. What 12c does is the ability to redact or encrypt our data and effectively mask it in real time via policies that are enforced at the user level. So here we have a payroll processing user who's able to see social security numbers and PIN numbers and various secure information, whereas a call center operator tries to query that information. And regardless of whether they're using an application or SQL+ or Toad or what have you, that data is masked at the database level as it is returned. So in terms of security, that's not only a great feature, but also an excellent way of having your data within pluggable databases secured. So I'm going to fly through a couple of these slides, but just to wrap up in terms of database as a service, what we're trying to achieve with it, what it gives us is the ability to formalize service levels, because now we're saying we have a platform that we're consolidating on, which is highly available and is also highly performant, because it's typically a high-spec platform. We can also reduce the complexity by saying that platform has to be Linux or it has to be Solaris, or we have a choice of the two perhaps. And give us a much more easy to manage environment in terms of Oracle versions and architectures. We can also define much more of a predictable IT spend model for when projects are being created, because we know exactly how much it's going to cost to host a database on this infrastructure. In terms of cost per transaction, just eliminating the silos and the sprawl of IT is a great way of reducing our operating costs, both in terms of our data center costs and our license costs. And we can also lower the time it takes to provision things and the agility that we have there. So yeah, I've already talked about performance, the fact that we're typically going to be running on much better kit at the back end. We can also improve security as well, particularly with 12c with pluggable databases. Single vendor support, I don't think that should be overlooked. If we're running on Oracle hardware with Oracle operating systems and Oracle databases running on those, there's really no wiggle room there for Oracle support when you raise an SR. Particularly with Exadata and the Oracle database appliance, you upload a single bundled file of all of your logs, including your firmware, your operating system, your database and cluster logs, and there's no reason for anyone to come back to you to ask for, hey, can you turn this debug on? Can you provide this extra log file from last week? They have everything they need, and the onus is on Oracle then to give you a solution. So I think that's a very, very important point. And I've already talked around the benefits of standardizing in terms of operating systems and database versions there. In terms of the different service levels we provide, we typically look with a database as a service at providing a gold level, which is based on a RAC, a real application clusters architecture, in an active-active mode. using DataGuard to typically a real application cluster standby environment, and with daily incremental backups, normally involving some kind of snapshot technology depending on the storage infrastructure. With Silver, we typically go either single instances or active-passive clusters using either Rack 1 node or traditional CRS clusterware type technology. We would still use DataGuard, and we would still go for daily incremental backups. Whereas in the Bronze environment, and this is typically for back office, departmental type systems, we would have single nodes, single databases, and weekly backups for those, as they're typically a lot less critical. So really, I think the key thing here is that we tier the databases according to the business service level requirements that they have. And we can bounce those around quite happily and upgrade, particularly with 12c, unplug from a Bronze area and plug it into a Silver area. So Oracle Enterprise Manager 12c gives us some really nice features here in terms of how we manage and provision into these environments. There's an idea of governance for resources and policies here. Effectively, what we can do with Enterprise Manager 12c is create a service catalog, and that service catalog can be things like build a new SAP database, build a new e-business suite database, and those can be scripted and given over to the user community to actually run if we so choose, depending on possibly levels of trust there. But the ability to have that kind of agility and scripted solutions is extremely powerful. So the self-service provisioning can be restricted to DBAs, developers, project owners, really depending on the business requirements there. And it really is as simple as running through a wizard to run some of this functionality. And again, this could be, I have a production database. I want to enable my developers to create a number of clones of that production database via a very easy and controlled method. And I want there to be service levels around those methods as well. So we can say to developers, okay, you can create your own clones, but you need to give us 24 hours notice so that we can, we can approve that and give it the green light. There are also a number of APIs which we can externally integrate into other technologies there. The self-service provisioning is very, very powerful here. We can allow people to create databases, schemas. We can allow them to plug into cloud databases. We can use RMAN for cloning or snapshot cloning as well, which we'll look at next. The cloning functionality is very powerful, especially if you have something like NetApp Flex clones or ZFS cloning abilities behind the scenes. But can also leverage RMAN to do cloning. So we can literally say provision a copy of my production eBusiness Suite 12 database onto this server, and make that a wizard-driven process that our users can run. The showback and chargeback is very powerful as well. What it allows us to do is literally say either we just want to show the resource usage for our different users and our different applications, or we actually want to charge them and come up with an amount in pounds and pence as to how much they've used, and charge that back in terms of CapEx to a project. And it really allows us to monitor a huge granularity of information. This is a list of exactly what we can monitor and what we can charge back based on. And not only can we look at things like how much CPU and network I/O and disk I/O has been performed, but we can actually charge back in terms of service levels as well. So the actual amount of database time that's been racked up, the user transactions as well. If we have an application which is supposed to be doing 100 transactions a second and it's actually doing 1,000 transactions per second, we can see that through these showback and chargeback modules, and actually bill the business for what they're using, which is a very powerful feature. Now, the last thing I wanted to cover here is how we actually achieve this from a hardware point of view, and I just have a couple of slides to wrap this up. But I think, as I mentioned earlier, what we don't want to do, I think, to enable database as a service is just, upgrade our RAM, put in a couple of new CPUs. I think what we really need to do is look at the whole platform as a cohesive element, and how our storage and our database service and our app service fit together. we think of that as less of a next generation platform and more of a new generation platform, or to coin another phrase, less evolution and more revolution. What we typically use as the building blocks for a database as a service architecture are typically either Exadata or Supercluster, or a combination of them, depending on the flavors of Spark versus Linux that are required, and the degree of WebLogic or middle tier applications that are being consolidated. We heavily use the database appliance as a tier 2 database platform, and we also use the ZFS, particularly these new ZS3 storage appliances, as they provide very high performance back-end storage, but also the ability to do the cloning, to do the hybrid columnar compression, and also the the different permutations of InfiniBand, fiber, NFS via NAS, and those sorts of protocols there as well. All of these are appliances. They're very extreme time to market, because literally you turn them on and there's a wizard-driven process to get them up and running. They're much easier to manage and upgrade because the fact that they're appliances again, and typically have much lower cost of ownership. So as I mentioned, not only do we get extreme time to market when you put in an appliance, but the performance is typically much better as well. Normally due to that huge pipe that we have with any of these appliances between our database servers and our storage, as well as the fact that these appliances are tuned for Oracle. It's really all they do and and what they're good at. So as I said, we have Tier 1, which is Exadata and Supercluster. And I think we could go into a much deeper dive around either of these products, but it's safe to say that they provide extreme performance primarily through a combination of very extreme compression, very fat pipes using InfiniBand between the storage and the database servers, and intelligent storage using Exadata storage cells to only serve the blocks we need, rather than just serving every block in a table. The Tier 2 or 3, we typically use the Oracle Database Appliance. It's a very capable 2-node cluster with some dedicated storage. And as a unified storage backbone, as I mentioned, we use the ZS3 storage appliances, mainly because of that benefit of compression, cloning, and the ability to have an information lifecycle management policy to move our data between different tiers of storage. And we're actually seeing, it's worth noting, on the ZS range of storage appliances, much more integration with Oracle 12c, and it's the only storage appliance which integrates closely with the 12c heat map and intelligent movement of data between tiers of storage. So what we end up with is, and apologies, this is kind of a busy picture, but this is the kind of tiering model. Tier 1 on Supercluster and Exadata, Tier 2 on ODA, and Tier 3 on ODA, normally with the ZS storage for our development clones. And the last point I'd like to make is that we, at Cintra, we believe in this stuff enough that we've actually bought it ourselves. So we have a data center in the Guinness building, actually, in Dublin, where we have our own Exadata X32, our database appliance X32, and our ZFS storage appliance there as well. So we can help out with proof of value or proof of concept exercises. We typically also test patches and that kind of thing there, so that we remove the risk of any of those patches having issues when we put them into our client environments. So that's all I had. I'm going to hand back, I think, to Sarah to kind of cover any questions that we had added during the session.
Yes, hello. So if anybody does have any questions, then please do feel free to submit them into the box now, and we can then obviously go through and answer any of those questions that you do have. So I'll just give a couple of minutes for people to submit any questions that they may have, and then I can read those out and then obviously hand over to Simon to answer any of those for you. Okay, so we've had a question come in that says, what was the point about the heat map only being applicable on ZS3 appliance? can't you use this feature on other tiered storage?
Yeah, that's a good question actually. So the answer is yes, you can use it on other tiered storage. What the ZFS appliances do will actually, and this is a very new feature in the latest release of their operating system called OS 8, is they will actually move data automatically for you between tiers and integrate with the Oracle heat map. So with any other storage, imagine we're running, I guess, a tier 1 SAN and perhaps NetApp NAS. Oracle will maintain its heat map and move data between the SAN and the NAS as we need to. It'll migrate partitions or migrate data between partitions as it needs to. With the ZFS side, what we can actually do is have visibility of the heat map from the ZFS analytics, which is a hugely powerful analytics tool. And we can also dedicate pools to say this is tier 1, this is tier 2. So perhaps have SAS drives versus SATA drives, high performance versus high capacity drives, and actually let ZFS do the tiering of those drives, as well as using its memory and SSD caches there as well. So I'd say absolutely you can use heat mapping anywhere, and it's a generic 12c feature that will work out of the gate. But ZFS has some significant advantages, both in the monitoring and the management of that feature.
Okay, so thanks Dan for that question. If you have got any other questions, obviously please do feel free to submit them now, so that Simon can answer those for you. Okay, well it doesn't seem like there's any more questions, so thank you for joining today, and thank you Simon for presenting with us as well. As I said, we will send out a copy of the webinar to you shortly, but if you do have any questions in the meantime, then obviously please don't hesitate to get in touch, and we hope to see you on another webinar soon. So thank you very much.